This video is about chi-square GOF test. In an effort to study the level of intelligence of students entering college, a psychologist collected data from 4,000 students who were given a standard test. The predictive norms for the particular test were computed from a very large population of scores having a normal distribution with a mean 100 and a standard deviation of 10. The psychologist wishes to determine whether the 4,000 test scores he obtained also came from a normal distribution with a mean 100 and a standard deviation 10. He prepared the following table. Expected frequencies are rounded to the nearest integer. A. Copy and complete the table showing how you arrived at your answers. Let's label this is A, B, and C. Based on the information given, we know the data follows a normal distribution with 100 as mean, 10 as the standard deviation. First of all, we need to figure out the probability when x is between 80.5 and 90.5. We will use norm CDF to figure this out. Let's go to calculator. Go to menu, 5, probability, 5, distribution. Go to 2, normal CDF. 80.5, 90.5. Mean is 100, standard deviation is 10. Enter, enter. 0.145468 is the probability. So the expected value equals, check the number of samples, 4,000 students. We will use this 4,000 times this probability equals times 4,000. Enter. Answer is 582 as integers. We will use the same way to figure out B. B equals 4,000 times probability of x greater than 90.5 less than or equal to 100.5 equals 4,000 times norm CDF 90.5, 100.5, 110. Go to calculator. Go up, pull this down. Change 80.5 into 90.5. And 90.5 will change into 100.5. Enter. Times 4,000. Enter. Answer is 1,396. Let's go to C equals 4,000 times probability of x greater than 100.5 less than 110.5 equals 4,000 times norm CDF 100.5, 110.5, 110 equals, go to calculator, go up, change 90.5 into 100.5. 100.5 turning into 110.5. Enter. Then times 4,000. Enter. Answer is 1,333. B. Test the hypothesis at a 5% level of significance. We will use chi-squared GOF test. First step, state HO and H1. Let's go back to the problem. The psychologist wishes to determine whether the 4,000 test scores he obtained also came from a normal distribution with a mean 100 and a standard deviation 10. This is HO. HO will be the 4,000 test scores follows the normal distribution with a mean 100 and a standard deviation 10. So HO will be the 4,000 scores are modeled by normal distribution with 100 as mean, 10 as a standard deviation. H1, the 4,000 scores are not modeled by normal distribution. Second step, we need to create the observed and expected frequency table. When we create this table, make sure all the expected frequency is no less than 5. Otherwise, you need to combine the expected frequency. Let's go back check the expected frequencies. This number is less than 5. So we need to combine these two together. 80 plus 4 is 84. 76 plus 4 is 80. Then we change this score into greater than or equal to 120.5. Now let's fill out this table. Then third step, we need to figure out chi-square equals summation of observed frequency minus expected frequency squared over expected frequency. Let's go to calculator. We will use a spreadsheet. Click on, press 1, new documents. No. Then 4, spreadsheet. Let's label the first column as FO, observed frequency. Second column, FE, expected frequency. Then you need to type in all the data for observed frequency and expected frequency. Next step, for this C, let's label as P. Then for this formula bar, we will double click to type in the formula. Parentheses, click variables, get FO, minus variables, FE, then squared, divided by variables, FE, then enter. Then move the cursor on any empty cell go to Menu. 3. Data. 6. List math. Go to 5. Sum of the elements. Go to Variable. P. Enter. You could say you got like a really crazy number here. Let's store this into a variable. Control variable store this one into B, then enter. Now let's add one more page. Control Doc. Add calculator. Go to variable. Get this B, enter. Go to menu. 2. Number. Convert it into decimals. Enter, enter. Answer is 61.3778. Then you can use a calculator to check whether you got a correct answer by finding p-value. Go to menu. Go to 4 stats. Go to 4 stats test. This is a chi-square GOF test, so go to 7. Click this right arrow button. To get observed value is FO. Expected list. Click this right arrow button. Pull out FE. Degree of freedom. You could say altogether 7 data for observed frequency. So 7 minus 1 is 6. Then enter, enter. So we got this chi-squared equals 61.3778. We got the same answer. So we are on the right track. When you write down your answer, remember you have to write down all the values from this column P. Now we got the chi-square value is 61.4. The next step, we need to get a critical value. Let's draw this chi-square distribution. This is a critical value K. This area is a significance level. In this problem, significance value equals 0.05. Therefore, this area equals 1 minus alpha. This critical value is related to significance level alpha and degree of freedom n minus 1. Check how many data we have. 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is 6. So critical value K equals, we will use inverse chi-square to figure out. We can use this scratch pad to figure out this critical value. Go to menu. Go to 5, probability. Go to 5, distribution. You could say inverse chi-square is 9 here. So press 9. Area will be 1 minus alpha, 1 minus 0.05. Degree of freedom is 6. Enter, enter. Critical value, let's write down the accurate answer. 1 minus 0.05, 6. Critical value equals 12.5916. The next step, we will draw the conclusion. We also know this area also called rejection region. If chi-squared greater than this k, then you reject HO. You know, we always remember place, which means when p-value less than alpha, reject HO. For chi-squared value and a critical value, you just need to remember this symbol switch. When chi-squared greater than critical value, reject HO. Let's write down chi-squared and this critical value, 61.4, 12.5916. Definitely 61.4 greater than 12.5916. Reject HO. We will rewrite down H1. The 4,000 scores are not modeled by normal distribution. Our conclusion, the 4,000 scores are not modeled by normal distribution with 100 as mean, 10 as a standard deviation.